Tell me.
That me? I don't know. He's probably cruising around in his new car somewhere.
What car?
He bought a sports car last week. It's one of those really powerful ones. It's like a suicide machine if you ask me, because if he would use all of that power, he would just like slide through the first traffic light.
Well, rapid braking isn't much of a problem these days, as all modern cars are equipped with an anti-lock braking system.
And anti-what?
Anti-lock braking system, ABS.
Well, I would understand what you would have said if you said ABC, but an ABS?
Yeah, it's been proven to improve braking performance by 30%.
It's quite a lot, isn't it? So, how does it work?
Come on, let me show you.
Alright.
ABS is a safety system that allows the driver of a vehicle to maintain control while braking.
How on earth did they come up with such a system?
Well, as threshold braking on airplanes is nearly impossible, there was a need to develop a mechanism to allow the plane to safely come to rest. So ABS was first developed for aircraft use in 1929. Come in.
Hello guys.
Hey Dami, I was just explaining to Spartak how an ABS system works. I told them that it was first developed for aircraft use.
Oh yeah, that's true. In the 1950s, Dunlop's Maxwell was the first ABS to be widely used. It was rapidly taken up in the aviation world as it led to a 30% reduction in stopping distances and the elimination of tire bursts or flat spots due to skids.
So, how did this early form of ABS work then?
This system was entirely mechanical and worked by measuring the speed of two spinning discs. Normally, with the aircraft wheel turning, the wheel would spin the drum, which would spin the flywheel, so that all of the moving parts were spinning at the same speed.
So when did cars get ABSs?
In the 1970s, during heavy braking, ABS prevents wheels from lock-up, as it helps the driver to maintain steering control. It monitors wheel speeds and releases pressure on individual wheel brake lines, and thus rapidly pauses individual brakes.
And what about modern ABSs?
Nowadays, ABS has an individual brake line for each of the four wheels, enabling different braking pressure on different road surfaces. For example, less braking pressure is needed to lock a wheel on ice than a wheel which is on bare asphalt.
So what happens if the left wheels are on tarmac and the right wheels are on ice?
During an emergency stop, ABS detects the right wheel is about to lock and reduces braking force on the right wheels, helping to avoid lock-up and loss of vehicle control. Let me draw you a picture to simplify the whole explanation. Here are the components of ABS. It is made up of four main components. There are speed sensors, valves, pumps, and a controller.
How do these sensors function?
They constantly monitor the rotation of each wheel to evaluate whether the system needs to be engaged to control braking.
So what do the sensors do when the wheels spin at different speeds?
The speed sensors send a digital signal to the ABS controller. This signal is generated by an electric field being given off by the contact between the sensor's magnet and tooth ring.
What is this controller and what's it do?
It's a computer in the car which monitors the speed sensors and controls the valves.
Alright, and how exactly does it work then?
Yeah, just before the wheel locks up, it will experience a rapid deceleration. If left unchecked, the wheel will stop much more quickly than any car code. It might take a car 5 seconds to stop from 60 miles per hour under ideal conditions, but a wheel that locks up could stop spinning in less than a second.
Okay, yeah, I guess it is impossible. Unless there's a wall in the way, of course.
Yeah, very true. The ABS controller knows that such a rapid deceleration is impossible, so it reduces the pressure to that brake until it sees an acceleration. Then it increases the pressure until it sees the deceleration again. It does this very quickly before the car loses traction due to sliding. The result is that the tire slows down at the same rate as the car, with the brakes keeping the tires very near the points at which they'll start to lock up. This gives the system maximum braking power.
How is the ABS controller physically able to reduce the pressure in the brakes?
Well, the controller uses valves in the brake lines to control the amount of pressure in the system. When a valve is open, pressure from the master cylinder is able to pass through the brakes, and when the valve is closed, pressure is isolated from the brakes.
Alright, but wouldn't you lose the brakes if pressure is released from them all the time?
Yes, but thankfully the system also consists of a pump which works in conjunction with the valves. When the valves reduce the pressure in the line, the pump increases the pressure afterwards. This cycle is repeated up to 16 times a second, preventing the brakes from locking up.
Whoa, I must try this ABS sometime.
I felt it vibrate in my leg. It's quite amazing. I guess the wheel was like blocking and unblocking at the time, and yeah, it's amazing. So what exact advantages and disadvantages does this ABS bring with it?
It reduces braking distances and enables the driver to maintain control in an emergency situation, which results in the reduction of severity of impact in an accident or even prevents it from happening at all.
Okay.
On the other hand, ABS increases braking distances in gravel, sand or snow. Statistically speaking, drivers tend to be less cautious when they've got ABS on their cars.
Okay. Yeah, makes sense. But anyways, I just want to try it without the ABS.
Okay.
Come on!
Oh, for the love of God, my leg. Oh. I told you so. None of this would have happened if you had ABS.
Now I know why they call this heavy metal.